I think my real interest, if I traced it back, was curiosity about the physical world, which is what physics is.
One might imagine, at least, that one's talking about nature when one's talking about the character of physical laws. But I don't want to talk about nature, but rather how we stand relative to nature now. I want to tell you what we think we know, and what there is to guess, and how one goes about guessing.
This is the piece of the equation which describes how the Higgs field acquires its value.
So welcome to episode number 54 of Physics Matter. So this monthly live colloquium series connects people around the world through popular science, highlighting capacity building in developing regions and the role of major research infrastructure like the Sesame Light Source, so in Jordan. So for more than 4 years now, so we have virtually traveled around the globe, and we have been exploring as well all those different places that you can discover through our website and our YouTube channel, so on the web. And we have all those recordings of those scientific expeditions and story about technology transfer in action available for you. So, but today we want to spotlight a spin-off from the Electra light source in Trieste. This is an inspiring example on how scientific capability as well and venture capital can meet together through industries. So our panel today includes Andrea Lossi, who is the scientific director of the Sesame Light Source, with Alan Hurd as well from Los Alamos, and myself, so from the European Spallation Source, so in Sweden. So both Alan and myself, so we have been sharing the APS, Forum of International Physics, which proudly support this event. So today we are honored to welcome Raffaella Geometrante. So Dr. Raffaella Geometrante has been managing, and she's the director of the KIMA SPA and the KIMA technology. So it's the Italian part and the Slovenian part. So that's why we have two flags today. So this is big, and she's a leading expert in a permanent magnet device, and she has helped a lot with advancing the production of key components like different undulator and relay, which are critical for the synchrotron and free electron laser facilities around the world. So in addition to her executive role, Dr. Geometrante has been co-sharing as well the Accelerator Science and Technology Industry Permanent Forum, which is a key initiative fostering collaboration between industries and research institutions. So with this role, she actively bridges the gap between scientific innovation and industrial application, driving more advancement, in accelerator science. So after about 20 to 40, I think it's going to be rather 40 minutes of her presentation, we will invite you to write your question in the Q&A session that you have just down there, or you can raise your hands and we can have you as well presenting your questions to our panelists. So we can then now start this vibrant event, and we have then Raffaella taking the lead.
Okay, so thank you for the great introduction. And let me share what I have prepared for today. Let me see if, okay. Is it fine for you? Do you see?
Works very well.
Thank you. Thank you. So Christine, when you asked me to give this talk and presentation, we discussed a little bit about the title, and we finally defined this accelerating innovation. I think that both accelerating and innovation is a keyword for the time being where we are living. We have right now to think about how to move faster and innovate. And so the idea here today is to tell the story of the company I'm managing, because it has this peculiar foundation, and then explain how we are going throughout research, development, and innovation in a way that we can collaborate with labs, institutes of research, and big, let's say, infrastructure. As you already said, I'm also co-chairing the Forum for Industry, Accelerator, Science and Technology Industry. And this is, I will come back later on that, because this is definitely something important and brand new in the panorama of Europe. So let's start from the beginning, from how KIMA was founded, because this can give you the DNA of the idea around which the company was created and why we behave and we move throughout the market in our way. So let me see if I can go ahead. Okay, so here is Fermi ad Elettra. You already anticipated a little bit about the story, in the sense that during 2005, 6, in the early 20s, the early 2000 years, here in Trieste, there was this decision and then the project to build a free electron laser. And the name is Fermi, and this project needed something like 20 ondulators. The know-how was very well developed inside Elettra, but the point was here that they needed to have something like a serial mass production of ondulators. And the idea was to found a company to bring inside the competence and the know-how of Elettra, together with the capabilities of industries which were willing to join this new co. And at this point, the company in 2007 was founded, as you can see, putting together the 51% of Elettra Synchrotron Trieste, and then the 22% and 27% of two industry, one into mechanical application and the other one on control system. The interesting fact here is that Elettra didn't put €1 in the company. The 51% is the know-how that Elettra brought into the company. So drawings, discussion with the expert of Elettra, in order to transfer the know-how achieved in Elettra. This was the foundation of KIMA SPA, which is the Italian one. The Italian one owns the 100% of Slovenian, in which we actually manufacture all the ondulators, where we have our lab, our manufacturing side. And just to tell to the people who are not familiar with the local, we are talking about 15 kilometers between one place and the other. Let's say in 10 minutes by car, I can go from the place in Italy to the place in Slovenia. And this was decided also because at that time, that was a border that was somehow disappearing thanks to the European policy and politics. And this was one of the first examples of a company working on one side and on the other side of the border. This is the building. So we are talking about real facts, about a real structure where we manufacture the ondulator. So this is exactly the picture of the place that we have in Slovenia. So let's go back to the original idea, the realization and manufacturing of the ondulator for Elettra. So here we have Elettra, as you can see, and also the free electron laser. And if you go inside the free electron laser here, we are in the undulator hole. This was a video made by Luca Giannessi. You can see here all the undulators that at the end Kima realized. So the plan was successfully achieved. All the undulators were delivered on time, on specs, and on budget. And the experiment was extremely successful, so that Kima started to go on to the international market. I put here some pictures of undulators. This big green one went to Korea, for example. On the left, there are the first of the 7 we have been doing for Brookhaven, for example. So we went from the realization of this initial design to many other designs very similar. But when it has to come to do something new, we started a new collaboration with new labs. For example, here is a picture of the C-beta magnets. The C-beta magnets are done together with Cornell and Brookhaven for the energy recovery LINAC. These are devices with permanent magnets, but you can see it's something completely different. The technology is related to permanent magnets, but the shape and the idea is something that was born in Cornell Brookhaven and together with Kima was realized. The same apply, for example, for this undulator. This is also a fixed gap undulator developed thanks to the idea of Sasha Temnik in Cornell. And just to give an example of another shape of undulator, this Apolex has been done together with INFN of Frascati. Why I'm showing you these kind of different shapes? To stress one thing, the fact that when we had to develop something brand new, the collaboration with the institute, with the university, with the lab has been essential and allowed us to bring to the market even other type and models of undulators. So let's say that the story of Kima is very successful. We deliver hundreds of devices. This is the list of customers. So this is, let's say, the beginning of the story. Right now it's more than 15 years that we are on the market, but there are important challenges for any kind of company. And this is why I really want to go into the detail of these challenges and to explain how we are managing these challenges. So as I said, Kima is doing very well thanks to this collaboration and thanks to also other interaction I'm going to explain very soon. The performances are in the last years have a four-fold increase. Contracts value is at 20 times of what was in the beginning. But still, the challengers are many. And here is a question that I'm posing constantly to myself when I have to understand the strategy and share together with the board of directors which are the strategies we have to follow. The challenges of this market is that the market is very volatile. There's peaks, for example, at this point, in this moment, we have peaks because there are lots of upgrades, but we do not know if these peaks will last forever. There's no standardization. There's no continuity in demand. So the point is, how can companies stay competitive on this market? So the solution for us was to keep in the company the essential know-how and competences, and so to be able to be very flexible. But at this point, we need also to innovate. And the key point here, and here I think is the most important, let's say, slide about regarding my presentation. And it's about how we can be competitive and how we can have a competitive advantage. And this is, at least from our point of view, strictly related to the rate of innovation. So it's important, the innovation, but the rate of innovation is extremely important. In fact, in this field in which we just describe as evolving very fast and market shifting even faster, the question is not just about innovation, but how fast we can innovate. The key point is, as I said, is not, yes, the size is important, the scale is important, but we have to stress the rate of innovation and to bring very quickly a prototype to be a product, and then from a product become a solution that creates value in the market. And so the key point and the constant question I'm posing to myself is how we can have this rate of innovation strong that allowed us to be competitive. Considering that we have a European market, US market, and also Asian market, and some markets are very, very fast in the decision-making and in the possibility of investment. So we have to be capable to be as fast as all the other markets. So giving this focus on this point, I want to go ahead emphasizing this with these slides, the fact that research and industry have to work together, but they are not the same thing. As I explained before, Electra knew about how to make state-of-the-art ondulators, but didn't have the goal or the mission in their, let's say, idea constitution to have a economic or manufacturing production. So we have to remember that research and industry are two parts that have different values, different goal. As you can see here, for example, long-term for research is pretty normal. There's lots of investment to have a long-term result. For company, the time to the market is essential. But here we have to remember that there is an overlapping area that where both industry and both research can go in order to enable the technology and in order to speed up the production. And let's right now, after this introduction that seems to be a little bit theoretic, I would like to go in concrete fact. So how a company like Kima can go ahead and innovate and speed up the innovation and bring rapidly to the market state-of-the-art components and devices. One option, for example, for us, which important has been this IFAST project, which is a European Union founded project. And IFAST stands for Innovation Fostering in Accelerator Science and Technology. This is a project that involves 49 partners, including 17 companies. And as you can see, we work as co-innovators. So we have an early engagement of the industry in order to have this rate of innovation that is higher. If industry is involved since from the beginning, industry can somehow bring to the project what could be the final idea that allowed this prototype to become rapidly a product. Okay, so this is a project started in 2021, and to give you the example of the project in which Kima is involved, one is, for example, this hybrid electromagnet, permanent magnet tunable optics. And this is done with UK Research Innovation and Diamond. And the idea behind this project on which we have been working is that that in order to allow the low emittance and the increase of radiation brightness in the 4th generation synchrotron, there's the need of to use the multiband achromat lattice, and most of them need function as a dipole and quadrupole magnets. In the case of a diamond, they are planning, or they were planning to have 48 of dipole quadrupoles. And the question was this one: can permanent magnets achieve the same purpose of electromagnet with a lower energy consumption? So going to what you have on the left, on what you have on the right, yes, the answer to this question is yes. In fact, we work all together. I do not want to go here into the technical details. I just want to show you this to give you the idea on what we have been working. The idea was to have this kind of pole with this specific shaped, designed by UK. We put together everything. And right now, let's say this is a photo, a picture I took yesterday, and this is ready for shipment and ready to go ahead in UK for measurement and possibly to be used in the next synchrotron, low synchrotrons. Another example is a variable dipole for Electra ring. The name is Father, and is done together with CERN, CMAT, Electra, and once again, KIMA is involved because we are talking again about permanent magnets. Let's say the Father perhaps reminds you about something, and here is the father of everybody remember, and the motto here of Yanis was "May the field be with you." So there could be also some sense of humor. But going back to serious stuff, the father object was to fabricate a dipole magnet prototype with also longitudinal varying dipole field, and which could be fitted with a transverse gradient, which could be even fitted to an Electra upgrade. The concept was already experimented and demonstrated by CERN and CMAT for the CLIC project. The idea here was to develop something that could fit a synchrotron. And these are the drawings, and right now we are procuring the different part which will, and we're gonna have also the realization of another kind of permanent magnet device. So these two examples gives exactly the idea of this kind of interaction that is very efficient and very well working for an industry like KIMA. We can develop together with labs new devices and make research and development that in a company that necessarily has to be of a certain dimension because of the variation of the market and the fluctuation I told you before. This, I would say for a company of this dimension is a way in which we can innovate and we can rapidly innovate, and not only because we have new devices, but also because we are involved in the design phase, and we can immediately address any issue that could become a concern if the prototype was developed only considering the physical, let's say, performances and not the future possible industrial application, because of course industry has another standard. So this is a way, but we believe it's very valid to allow the labs and the industry to work together, allow labs to have a new company to develop new devices. Once again, here we can also think about having some standards. This could be a great idea to develop this prototype and understand that with minor adaptation, this could be good for everything. So industry, needless to say, is pushing towards standardization, but this could be also convenient for labs. If you know that there are some specific standards, perhaps you can satisfy your requirement faster and spending less money. Okay, this is a way. Another option, another, let's say, a project in which Kima and personally I are deeply involved is the permanent forum of industry of the accelerator in science and technology. This is AIPF and was endorsed by Tiara in 2023. So it's 2 years that we are moving on. And this was established to bring together the accelerator and science technology community, which is very important, to foster a coordinated approach between industry and research institutes and increase the innovation capacity. This is, let's say, composed by people from industry. You can see 7 people from industry, 7 people from research institutes. We have 2 ILOs and, of course, Jose Manuel Perez for Tiara. Isabel Bejar Alonso and I are co-chairing this forum. And the great characteristic and the idea behind this forum is this word behind, of course, many other ideas, but this word in yellow, permanent. In fact, we have many advisory committee along with the project that can last 3, 4, 5 years. But after that, all the know-how of all the experience acquired during the project disappear because the project ends. And so the idea here was to keep something permanent, to have, of course, some changes and new people getting in and getting out and sharing or contributing. But the point is to keep alive in a permanent way this forum in which we can discuss about the future and how together and how to bridge together industry and lab. So I'm often asked why I dedicate time to this forum, especially when running a company is already, let's say, keeping me quite busy. But I really consider this a personal, motivational goal, because I really believe that we have to and we need to build a common ground. And Isabel and I, together with all the people, are really trying to build something that's going to last and going to keep experience inside the forum, and a space where industry and research can be equals and can meet in that area of the drawing I show you on the overlapping in an equal way, discussing about innovation in not only in parallel, but also in a synchronous way. And so what we have been doing up to now, we made several discussions. We were involved in as a consulting, let's say, entity when industrial vision is requested. And we pointed out some priorities, and these 5 priorities. I have here listed, but you can find on the sites of the permanent forum that you can find also in the previous page. And as you can see from our discussion of these 3 years, we identify some priorities, and each of us devoted our time to the fostering and the support of one or more of these priorities. So we consider that one of the important priority is the integration and classification, and in general, the distribution of information. What does it mean this? It means that sometimes information are not easily communicated. We are somehow fostering a classification system or a sort of a directory with keywords that allowed to understand for an industry, for example, that is not already working in the accelerator field, but is willing to get in, to understand exactly and in a fast way if this company has the capability and the knowledge to get in and to satisfy what is requested. We develop a matrix starting from the plans approach, and we develop something on that field, and we are promoting in order to have a sort of simplification and standardization in all Europe. The second priority for us is the involvement of industry in R&D funding programs. And this is definitely happening. When we have a proposal and there is a call, easy call, and some entity needs some input from industry, it's very difficult to go to one industry or to another company or whatever. It's much easier to go to the permanent forum and we together discuss. We share, for example, a proposal, and we give our advices, our indication, giving how industry together with labs see this proposal. So definitely we are already involved in several funding programs and with great satisfaction, I have to say, of the people involved in IPF, but also people who are preparing the proposal. Regarding the promotion of a mechanism to share risk, this is another important point in the sense that for the company getting into a project where there is a prototype with low TRL, for example, could be risky. And the risk cannot be managed only by the company, but it has to be well understood and shared together with the community, especially or inside of project, when we have to push for a new innovation. In this field, for example, we are collaborating with Ermin Network, that is a network of enterprise risk management, and together we are trying to address this mechanism and how this can be, the risk can effectively share and allow more company, more labs to work together. The strengthening of the relation between industry and research institution is another important priority for us. It means that we are working here to allow a technical industrial involvement in the cooperation or at the technical level. So we are pushing and finding way to work together from the technical point of view. And the last but not least is to promote the integration of roadmaps with our community. So we are in contact with synchrotrons, light sources, fusion, space, in order to build common strategy and ground to maximize effectiveness and research and development funding. So here is, let's say, a general perspective I'm giving about this forum, and I hope I was capable to deliver the power and the strength that this forum is bringing to Europe, even if it's 2 years that we are working. I'm sure that you will hear about this forum more and more in the future. So what's next? As I already anticipated, next, there's lots of European proposals where, thanks to the forum, we see more and more industry involved in the proposal evaluation, but also in proposal submission. As a forum, we've pushed the fact that it's important to have an early engagement of the company. So any kind of issue could be addressed as soon as possible. So definitely this is something that is going in the right direction, and the next proposal, next funding project will see industry more involved and the forum even giving a great contribution. Regarding KIMA, so going back to the beginning, definitely KIMA is doing, as I say, very well. But managing a company like that, you have always to push forward your vision and understand what's going to happen in the next years. And up to now, the involvement of Kima in projects such as this IFAST or for the Permanent Industry Forum has been really successful and allowed us to navigate through innovation and through R&D in a very positive and satisfactory way. And said that, I would like to conclude with one unique conclusion. So I really hope to have shown and demonstrate you that a world like this one in which we are living that moves fast, no one can innovate alone. And I strongly believe that the future belongs to those who collaborate to accelerate. So this is my conclusion, and I hope and I'm sure there's lots of question and discussion we can do around that. And of course, considering that I gave a perspective of a company, but as a spin-off company, so it's something that is on the border between labs and industry. Thank you.
Thank you very much. So to give and to have given this nice perspective, very comprehensible as well, on something which is, as you said, so the edge between those research infrastructure and what society really need, how to accelerate and the vision as well that your company has. So thanks to your leadership. So thank you very much for the presentation. So please, everyone can enter so your question in the Q&A, and we can otherwise also share the microphone so that you can ask live. And I have also a few questions. So we start with Alan, so who will speak live.
Thank you, Raffaella. That was really interesting and innovative. So congratulations. I'm curious about a comment you made regarding the forum, AIPF, that the forum is engaged fully in finding funding for R&D. And I wonder if you could say a few words about that. One of the motivations I have for this question is that when I first met Andrea Lausi in, I believe it was 2013, I was part of an IAEA review, and we visited Elettra, and Andrea described, I believe it was you, Andrea, that described the innovative funding for Fermi involving government loans and that sort of thing. So I'm curious, how is the forum approaching R&D funding?
Okay, but just to make it clear, yeah, the forum, the permanent forum, somehow is a place where industry are collecting ideas together with labs. So it's not directly that we are capable to collect funds, but we know for sure that the funds, at least in Europe, for the future project, are giving to those projects where you can see collaboration between industry and research labs. So the contribution of industry is related to giving this kind of shape and meeting this kind of expectation coming from Europe that is willing to fund opportunities as long as there's a possibility of labs to work with industry and industry together with labs. So in this way, we are, let's say, working in a way that we can represent somehow a part of industry and the common voice of industry and labs. And I think this is important because without an entity like that, where you have common voices. The risk is that you go to one on the other company with a risk that you miss somebody, or you do not exploit all the possible options. So somehow the forum is trying to bring together a mass of industry and also of ideas and contributing through it. I mean, this forum is done on the base of our time and our willingness to give a contribution and spare time to this. So is in this field not physically bringing, but is answering somehow to the request to see more and more industry and labs working together in this sense. Hope I have been clear enough on that.
No, that's great. I think that's a good answer to a very complex problem. Thank you.
And maybe I can also read the comments from Carlo Rossuto, who is also...
Carlo Rossuto, who is, I mean, the person who gave the idea of Kima. So he's, let's say, a key person. And I didn't know he was attending, but it's a pleasure to see his comment. Yeah.
So you agree about his comment, so saying that this forum is very useful, and when it's using as well these bank loans, so to allow for the calculation of the risk and the related interested rates as well.
Yeah, yes. In fact, this is something that we should have definitely, we are trying to tackle. As I said, it's 2 years, but we are working on that. Definitely the calculation of risk is extremely important when it comes to money, because money are more expensive, higher is the risk. But if we can understand what is the risk and we know how to mitigate, or we can mitigate together, definitely we can have a win-win situation for everybody.
By
So
the as well, I guess, the distribution of the different tasks from the prototype aspect. No?
Yeah, exactly. Because sometimes, I mean, if we go from in a prototype, you can be a company can be reluctant to get into, because if a TRL is very low, and you have to push a lot before achieving a TRL that can be, let's say, useful for the industry. And also regarding TRL, something that is considered high in TRL for labs is not high enough for industry. So something that in the labs is considered ready for market, then when you have industry arrives and says, no, this is not, you need 5 more years to get into a market. So this is important. Early engagement and understand, in case of early engagement at low TRL, if will not succeed, who's gonna take care of that? Who's gonna pay for that? Or who is the owner of the risk? And this is why we are in the discussion of the risk management.
Very good. So then we have another question. So from Keru Campet, who is asking, so with being a kind viewer, so watching from chess. So as he thought his career, so in the accelerator industry, so he continues to be striven to strive to learn the language of the industry. So really liked the mission that you were proposing, so providing distribution of information. So can you give a detail on how this mission so will be practically implemented? So what challenges have you faced so far? What did you
Sorry, I was reading the question in the chat and I lost the beginning. Can you repeat the beginning of your question? Sorry, because I was.
So sorry, this is about the mission and the vision as well that you gave to improve the distribution of the information. So the language of the industry.
Yeah, as a form, yes. Yeah, the point is this one. If you are a company and let's say you want to go into the market, you go to the BSBF, Big Science Business Forum, and you see that there's millions of projects going on and procurement that should be done very soon, and you want to get in. And you try to go through the documentation, and sometimes it's scaring for people who are not used to our environment. They don't even know if they have the competence and the capabilities. So what is Netherlands doing right now? And so we adopted a system like that and try to extend it. They are saying, let's say regarding, I make an example, we have to work and realize specific vacuum chambers, let's say, something very, for us, quite easy. But this has to have this characteristic and a list of specs. So we are trying to point out which are the competences that the company needs in order to satisfy those specs. So the company see that you need precision, you need to be capable to extrude, you need to be capable to have a clean environment or something like that. But allows the company to understand if deliver these kind of things, because we strongly believe that more companies are interested in the accelerator market, better it is for everybody, because the market is huge and is good for the laboratories, but also for the companies. I believe in the collaboration between companies and labs, but also between companies. For example, Kima, in order to develop and manufacture in vacuum ondulators, we are collaborating with another German company. We put our competence together and we work together. So the great message here is that we have to be more and more aware about that. And going back to Carlo Rizzuto's question, industry can bring also this perspective and understanding of what does it mean risk, what does it mean loan, what does it mean money, because we have to deal constantly on that and with that.
Yeah, excellent answer. And indeed, this is like the language which is as well given. So the industry and the societal aspect as well, more than the R&D level. So the one that enable and that give visibility as well to the product that you're providing. So we have a question from Andrea. So maybe.
Yeah, I just wanted, first of all, just to thank Raffaella for, in a way, also continuing transmitting the same kind of excitement that we all had at the time Kima was founded in Electra. You still have the same energy and the same excitement. That was great times, and they are still great times. Thank you very much, Raffaella. What I wanted to add is something to what you have just said about the collaboration between industries, which I just witnessed in these days, because we are going to receive in a couple of weeks the very first beamline built into Kiev. And this is something which needs exactly that kind of synergy among competencies of which different industries can have, because it's relatively easy to find somebody who can deal with vacuum at one side, or somebody who can deal with fine mechanics on the other side. But to put together these two kinds of competencies brings the entire industry to a different new level. And I hope we have the very first company in Turkey which is able to provide mirror chambers for soft X-ray beamlines, which is, well, it is some result, yeah? And so we hope to continue.
Yeah.
And by the way, the triple wiggler you built for us is working like a charm. Thank you very much.
But after that, for example, we have been asked also by Poland also to have something very similar to your triple wiggler. So somehow, you see, I mean, we are talking about real life. An example is a triple wiggler design from an idea from a Sesame became a product, and right now there is another one in Poland. And I can tell you that from the future proposal, for the future, let's say, funding, we are also thinking about in the future to further develop this idea of this kind of wiggler. So this is why, I mean, it's exactly fitting what we said. And then going back to this complex system, I believe that the systems that we have to manufacture and use in the labs are more and more complex, and we have to be faster and faster. So the idea of one man show, let's say, or one company or one team working alone to innovate is no more applicable. So we definitely have to find ways to work together. And yes, definitely the enthusiasm in Kima is huge. The idea is great, and it's fantastic to know to be a reference company in a worldwide panorama for permanent magnet devices, and thinking that this was born inside in a lab. So it's a very successful story. When we talk about a societal impact, these are the story I think we should all think about that and push towards that. And in order to push, we have to allow the environment where industry and labs can talk together. I think that one of the great, how can I say, strength of Kima, one of the great legacy of Kima from Electra is exactly the capability to be able to have an industrial mind, but with competence and capabilities that allowed us to interact with the laboratory. We, at the end of the story, it's always personal. It's always about one person from industry talking with, let's say, in a framework of a project, talking with a guy of a lab, and they trust each other and they are speaking the same language. So we have to find ways to promote this kind of environment. And Kima, let's say, because of this DNA, is somehow showing that this is feasible and can be done. Is a fantastic business model from my point of view.
It is for sure. So we have another question also. So speaking about maybe IFAS and also with Thomas Brand. So he's asking, so if you could speak a bit more about how bridging, so it's in this standardization. So when it comes to designing parts for accelerator, light source, how could it be also beneficial also for companies?
But you know, the point is that we have to understand that not everything has to be standardized, but something can be standardized. And this would allow us to, let's say, have some schemes, some engineering that can be done, and then with minor changes applicable. I give you an example. One of the three pictures I show you regarding products developed by Kima together with Institute, there was the last one, our orange one, the Apple X. Okay, this is an Apple X that was developed together with INFN, and we have 3 modules. This is a kind of undulator that we would like to further exploit and achieve a design that can be applicable also to other, let's say, facilities. Using, for example, the efforts to design the mechanical part of the control system part and changing the magnetic, for example, part. So this would allow the fast production and lowering the cost if this is feasible. So an idea born on one project could achieve some standards if it's possible. And I think each of the lab has his own unicity and unique, let's say, approach and goal. But some of the bricks that build these technologies can be standardized. So this is something that we truly believe would be good for labs to have a faster and cheaper, and also for a company, because if you start to have a sort of a mass production, or at least a serial production, you can scale up a lot from the economic point of view, and have a constant production is a dream sometimes of the companies working this field. In fact, for Kima, starting with 18 ondulators divided in few families was a great beginning. And so we know how beneficial this is for industry and also for labs.
Indeed. So the quality that then becomes as well the quantity, so towards mass production. So maybe
Yeah.
as
Not we can think together about pieces, bricks of these technologies that can have some standard, or at least I think that as companies we should push towards that direction, then see how far we can go.
yeah, it has to be a benefit. This is also the thing. So mass production could have, and any kind of pattern, or maybe we didn't really mention so much on that, because this is really also the difference between research infrastructure and industry. Are there any kind of pattern when we speak about standardization, so towards those that have to be involved? Were there pattern, for instance, from Electra that it was enabled for you to be able to develop further equipment?
You know, regarding patent, it's a little bit difficult to cover or protect at least what we have been doing. Lots of, let's say, strength of Kima comes from the know-how. The fact that we have been working for many, many years, and before Kima, Electra have been working on the undulator for many, many years. So there's some patents going around regarding ondulators, but right now being still changing a little bit, you do not need them to follow. So it's not always easy. At least from my experience, my personal experience was not easy to protect some specific approach. Nevertheless, for the future, if we go towards some standards, perhaps a patent would be useful.
Exactly, and I know that so Michel Baron will have to leave now, but I just want to read so his question with this HEPTech, also for high energy physics, this transfer of knowledge and technology as well, enabled by the research infrastructure. So he's also a member of this organization, and he's saying, so which impact, so the actual geopolitical status will have on the availability of the rare earth elements. So that's
rare earth, sorry, the
yeah, exactly. I mean, kind of equipment, material.
Okay. We the core of these permanent magnets are rare earth. We use neodymium, iron boron permanent magnets, samarium cobalt. Sometimes, and definitely this is something on which I think we should work all together in Europe for at least what were the plans since last year to have a climate neutrality. In the next years, we need some strategic technologies and lots of raw materials for that, and permanent magnets are one of them. At the moment, we have the permanent magnets. We buy permanent magnets from China, but through our collaborator, with whom we selected a very, let's say, one of the biggest permanent magnets company over there. And we have an agreement. Right now, things are moving still very well because we do not have dual use of a permanent magnet, stuff like that. But still, this is a place where we have to pay lots of attention. There's also a European supplier of magnets with excellent magnets. But in the past, at least, we needed to have a very fast delivery because we were very fast in the manufacture of ondulators. So we have to go there and verify how. Definitely, there's lots about permanent magnets. I would like to see Kima more involved in the sustainability, so in a sort of a circular use of these magnets. I would like to understand a little bit better how can these magnets be reused and be a player on that. In fact, for IFAST project, together with CERN, ALBA, Elettra, and other partners, we pushed to have a permanent magnet workshop in Trieste to discuss about this issue. And end of June, there will be an important workshop in Japan on rare earth. In the case of Trieste, we talk about permanent magnets in our field, but the workshop of Japan will be a little bit wider. And I'm following with lots of attention the development because the world is rapidly changing. And we have to take care of the fact that there could be several suppliers. But as I said, we have also the possibility European supplier, very good. And for us, it was a question of having a direct control of the manufacturing and a fast delivery.
Very good. And if we look also a bit at the developing community, so we have here also a question or a comment from Fadeli Al-Fatesh from Yemen. So he's also a member of the APS, so the American Physical Society, and he's curious to know which type of advice so would you give to a young researcher from developing community and from developing country as well, so who is aiming to bridge the gap between academic research and industrial innovation. So which are the kind of opportunity that you're thinking of, so for collaboration or mentorship, so through the APS or else?
Yeah, I personally, once again, this is something I truly believe in. I'm very supportive regarding mentorship or mentor. I think it's very important to have a possibility to share our experience and to give the perspective that we learn along our years in this world. And definitely, it's very important that everybody is involved in this kind of circuit. I know you, Christine, are working hard on that and sharing this know-how and bringing the ideas and in the countries, let's say, that are still developing new technology, new ideas, for people who are capable to know before and better, there's a lot of options also to have an impact directly in their own country. So I think that mentoring conferences, having also projects in which people are spending time in specific facilities in industry or stuff like that could really help to once again create a community. I really believe that despite everything's happening right now, the sense of community in the sense of bringing something to a group, it's very important, especially when you want to innovate. So I totally support this kind of project in which you can have exchange of people. I believe that the people are the key point. We have to create the frameworks, but at the end, you have to allow people to talk between each other.
So indeed, the people and the knowledge. So indeed, and I would there also mention the African School of Fundamental Physics and Application. So that we have every 2 years in different African country, and indeed we have this mentorship approach as well. And as you said, to bridge with industry, because this is how the sustainability in the society will enable the knowledge from basic science, pure science into the society and building. So those bridges is essential. So I think indeed. Go ahead, please.
Yeah, what I wanted to say that a risk that I see quite strong right now here in our community is that we have many facilities going ahead with great upgrades, new facilities, and people, we need new people, lots of people. For example, even hiring people in Kima is not easy. I mean, even if we have all the flexibility and all the possibility, so we really needed to attract and retain as much people as possible, and passionate, because as Andrea said, the characteristic of the people working in our field is the passion and the willingness to give an impact to the future, to the experiment you are doing, to everything in the future. And we have, as a community, to think about how to train and create the young generation of students, of engineers, physicists, and researchers who will be then involved in our fantastic laboratories or industries. So definitely is something we have to pay attention on that. I would also like to have committees with people coming from country under development, young people, young scientists, willing to tell their perspective, because we are guessing what could attract or what could retain these people. But perhaps could be good to ask directly to them, to give them a specific goal and say, listen, tell what you would like to have to stay there, and to what is your priority. I don't know, perhaps having flexible, a good compromise between life, personal life, science, or whatever could be an added value. For other, they don't care. I mean, it would be interesting to understand also, have an open communication on that with people.
Open communication, and to use as well the modern technology. Between now, the distance can be no problem thanks to internet and thanks to capacity as well to exchange, so communication again. So we have another very interesting question from Saif Ullah, so who is coming from the Institute of Space Technology in Pakistan, and so he's got learned a lot, and there are two parts in his question. So modern accelerator and technology demands a tremendous effort, especially when it comes to upgrading existing infrastructure. So could you share how much progress so you have made towards your goals so far? And secondly, how crucial so this collaboration, so both interdisciplinary and international, so has been advancing your work?
Okay, so from the last one, I believe that as we are facing rapidly fast-moving periods, what we have to count is on the competences and on ideas that we have, because very often all the rest change rapidly. So when you have some ideas in your head is a good point. And your ideas has to be shared with the other people with different background. I believe that we need to have, for example, from industrial business model, new way to make companies and to progress in the company, and the same for the labs. The example that Andrea brought regarding the beamline, it's a way of approaching and giving a solution that is different from the past. So we have constantly be innovative, not only in what we build, but also in the way in which we think. And in order to be there, having diverse background, diverse age, diverse everything, allowed us to put together new ideas to be consistent with the rate of innovation we want to keep and to be fast. So I believe that when you have to make a decision, before making a decision, in order to have a very rapid decision, you have to understand and analyze very well all the differences before. So only when you have a clear understanding of all the differences, but it's around, they are around available, you can make a fast and rapid decision. So definitely, I believe it's important. This is the second. Sorry, can you tell me about the first part? It was about upgrade.
So the first part was about so the progress made towards the goal for the infrastructure, existing infrastructure, and how critical it is with the collaboration, interdisciplinary and international.
With upgrades, regarding the challenges that we have as a company when it comes to upgrades of facilities. So, okay. I don't know if I understood very well the question, but what I can say is that right now we are working a lot with low emittance synchrotrons upgrades. And that means that we can go with the magnets much nearer to the beam, and that means that lots of new devices are needed. There's some other devices and things that can be used in case of upgrades, but anyhow, there's many new devices. I don't know if I caught the sense of the question. Hope so.
I think you do, yeah. And indeed, we have also, so from, so the APS as well, from the International Forum of Industry and Applied Physics, so with Thomas Metzer, so some suggestion as well to connect with the APS, so with the FIP. So, and I will give information there.
Yeah,
They are
sure.
very and a very large group. So for certificate of attendance, indeed, so it's really for this participation of all the different person from developing community. We did, and we could send that. So again, send me your email, so Faid Ali, so
Yeah.
I can do that. We have another comment, so from Nauri Camper, so who is asking, so about the industry, the market, so wondering the competitivity as well, the competition, so looks like for some specialized field. So maybe you can give one or two examples, and how is it between companies or between companies and in-house production? So competition.
Okay, for Kima right now, the biggest competitor is in-house manufacturing. But this depends on the approach that each lab has. There's laboratories who has large teams of ondulators, and they are willing to do by themselves. For example, in May, we're gonna be in June, we're gonna be in Taipei for the IPAC 25. So Taiwan deliver and manufacture their own ondulators, and they are very, very good to do by themselves. We sometimes collaborate with them in procuring, for example, part of their devices, and they do by themselves. Nevertheless, we are always in a total and open discussion, and when it's possible, we collaborate for part of that. Regarding our other companies, I have to say that there aren't many around right now, in the sense that in the past there were other companies, but at the end they decided to focus on, for example, electromagnets or other kind of components, because insertion devices are quite tricky and you have to be consistently good and specialized. When it comes to, as I say, step farther in the ondulators field, as I said, I like to collaborate with other companies. So I totally open if there is the possibility to collaborate with other companies. And then if you are in competition, you make your proposal, and and the best gonna win. So I believe that good competitors push you to do the best. I'm not scared as long as it's fair and is well done. In the case of Kim, I have to say the competition is in these months, in this year, is really not that strong, because we were capable to really gain a piece of market, and also to gain, how can I say, a recognition worldwide. So this is definitely, but nevertheless, we have to be always very careful, and be always capable to move on, and being always better and better.
Indeed, and you have there as well equivalent comment as well. So from Thomas Mercer, speaking about the balance between the collaboration and in the industry as well, and the in-house. So it's really a balance to find, so that there is competitivity that is
But
done in
I
the
think, in-house, sometimes, once again, do you remember the photo, the picture I show and I share regarding research that are developing state-of-the-art? Another great thing is that sometimes in the labs, there's the development of new concept of devices. And then this could bring new ideas, a new chance to all the environment. So the point of KIMA is to be considered reliable in order to understand, so that a laboratory can decide whether to keep the risk in-house and manufacture the devices in-house, rather than having outside somebody reliable who can do it. So it's a question then to have a choice to do so. I think it's perfectly fine, and this is beneficial for the entire community.
Very good. And I have put as well in the chat, so the link to this IPAC insertion device workshop that you have for the future.
Yeah. There's this workshop on insertion devices that will be on the 31st and 1st of June, 2 days before IPAC. And, also a nice thing of that one, this is a workshop dedicated to insertion devices. And the decision was to ask me to be part of a SPC, of a scientific committee. So I think this is a very nice, also, I've been asked to be in the SPC of previous IPACs, stuff like that. So having people of industry involved also in, of course, the participation has to be honest and fair. You cannot push, your own interest. You have to push a vision that is an industrial vision. I think it's really working and allows to keep on working together.
Yeah.
So if somebody's going to Taipei and have a chance to be there 1-2 days before, there's the very interesting workshop on ondulators with all on session devices with all the most important specialists and experts.
Yeah, and indeed, looking at also travel exchange. So it was nice, so Alan, to recall with the FIP, with the APS FIP. So we have as well a program to provide financial contribution as well for travel exchange program called the ARPAC. So you can look at our webpage, and it could be potentially for such type of workshop, and especially as well for coming for the APS meeting. So that's another set of a program that APS, that FIP is offering. So, and I would like to finish by a hand which has been raised already for quite some time. So thanks you for your patience. So Zain Abba, so I will give you the microphone so that you could speak and ask your question live. So where are you coming from and what is your question? Can you speak? Can you unmute your microphone and ask your question? Is it okay for you, Zain Abba? Yes. Please ask your question.
Hi, am I audible?
Yes, you do. We can hear.
All right. So I am Zain and I am from University of Agriculture, Pakistan. So I am also a founder of Pure Sense. It is a clean tech startup that focuses on making a physical product air purifier that works on quantum capture technology. So in my startup, I have some obstacles, like I am facing some obstacles in research and development, R&D. So I want is in the panelist, there is any panel who can give me advice. So how can I explore opportunities for advisorship or anything that I can make my startup complete. So my problem is that I am facing research and development obstacle. So this is my uh, problem.
Yeah. Yeah,
Which
I mean, this is a problem for any startup. My understanding is that you are from Pakistan, or did I get it right?
Yes, I am from Pakistan.
Yeah, so I do not know how it works in Pakistan. This is, I have to be honest, but uh, I believe that at least what worked for Kima, definitely to have as a founder somebody, Electra, who could, let's say, address and help and promote this kind of know-how. And I don't know if in Pakistan you have this kind of project. Europe, as I said, we can work on research and development thanks to the European projects and the possibility to collaborate on that base. I don't know how this can be applicable to Pakistan, and if there is any kind of support on that from the government, because at least from our experience, this is how we can move on. Of course, we do also some development in-house, but these are, let's say, related to specific projects, specific contracts that we have already there. Or it would be important on your side to understand which is the market you can gain, which are the potential interest in this kind of product you want to have, and ask some of your potential people to be interested in that, to get into the business and support you in this phase. But I do not know, I do not have experience in Pakistan in Asia.
the case of Pakistan, but you are part as well of the APS community, isn't it, Zain? So, and that could be potentially also nice for you to chat with people from the FIP that we were discussing about before. So indeed, connection also with, you are part of the APS, isn't it, the American Physical Society? So you are connected also with the APS,
Yes, I
correct?
am part of APS.
So through the FIAP, through those forums, exchanging information. So while you are coming as well to, or if you are coming, if you manage to come to our APS meeting or through the satellite meeting as well, it could be an interesting part actually, the one through Pakistan as well, to try to promote this aspect as well of how industrialization as well could be foreseen. So we can follow up on that. So, but thank you very much for your question and for the company as well, that hopefully will be very successful in this indeed geopolitical time, which is never easy, but again, like union, so make as well the strengths. So this is why also we need to maybe finish on this note. So with having again, so the possibility to thank you very much, so Raffaella, so for this presentation.
Thank you.
Very interesting to connect with industry. So we have now also possibility to expand. So this idea of so the reason why physics matter. And I just want to finish so by sharing so my screen to introduce the presentation next month by one of our young fellow as well. So with Niloufar Jakar, who is coming from initially Iran, but she is so also the president of the International Association of Physics Students, the APS. So she will give her perspective, so in May on the 22nd. And I think it's really important to enable so industry, but as well the youngest generation. And she's also connected quite intensively as well with a different working group in the IUPAP, so in the International Union of Pure and Applied Physics. So every international aspect is fundamental so that we can create a better world. So thank you everyone to participate, and so for this lot of questions, as you can see, so but I think it was really appreciated, and thank you so much for your answers, and let's stay tuned and we will meet later on. So thank you everyone.
Thank you. Bye.
Bye.